Hey guys, in this video I'm going to go over questions 1, 2, and 3 from the 2020 AIME 1. This is question number 1. It says, in triangle ABC with AB equals AC, point D lies strictly between A and C on side AC, and point E lies strictly between A and B on side AB such that AE equals ED equals DB equals BC. The degree measure of ABC is m over n, where m and n are relatively prime positive integers. Find n plus n. So the first thing we got to do in this problem is to draw a diagram, right? So we have an isosceles triangle ABC, where AB is equal to AC. And using the criteria that we're given, we can find that E is around here, D is around here. And if we connect these, we know that AE equals ED equals BD equals BC. So since we have a lot of isosceles triangles in this problem, we can basically continuously apply the base angle theorem and try to find a relationship eventually to find what ABC is. So the first thing we got to do is to set BAC equal to x and go from there, right? So if this is x, this has to be x. And since the angles in the triangle add to 180, this is 180 minus 2x. So now we know that this is 2x. And since this is an isosceles triangle as well, we know that this is going to be 2x. This is going to be 180 minus 4x. And since these three angles will add up to 180, this is going to be 3x. Since this is also an isosceles triangle, this is going to be 3x. And this is then going to be 180 minus 6x. So now we found a relationship because we know that since AB equals AC, these two angles will be the same. So basically we know that 180 minus 6x plus 2x equals 3x. And if we simplify this, we're going to get 180 minus 4x equals 3x, and that 180 equals 7x. So x is going to be 180 over 7. And if we plug this back in to 3x, we're going to find that this angle right here, which is equal to ABC, is going to be equal to 540 over 7. And since we're asked for m plus n, if we add these up, we're going to get 547, which is our answer. So this is question number 2. It says there is a unique positive real number x such that the three numbers log base 8 of 2x, log base 4 of x, and log base 2 of x in that order form a geometric progression with positive common ratio. The number x can be written as m over n, where m and n are relatively prime positive integers. Find n plus n. So in this problem, the first thing we got to notice is that log base 2 of x is always going to be 2 times log base 4 of x. And so we know our common ratio. And the reason I know that is because if you use change of base on log base 4 of x, this equals log base 2 of x over log base 2 of 4, which is log base 2 of x over 2. So if we apply this common ratio on the first two terms, we know that 2 log 8 of x, 2 log 8 of 2x equals log 4 of x. If we use change of base on these, you can get 2 log base 2 of 2x over log base 2 of 8, which is 3, equals log base 2 of x over 2. And if you simplify log base 2 of 2x, it's going to be equal to 2/3 log base 2 of 2 plus log base 2 of x. And that's going to be equal to log base 2 of x over 2. Log base 2 of 2 is just 1. So we basically just have 2/3 plus 2/3 log base 2 of x equals 1/2 log base 2 of x. So basically now we only have one type of the term. And so technically we just have one variable, one equation, so we can just solve this, right? And if we solve this, we can get 2/3 equals negative 1/6 log base 2 of x. And if we multiply each side by negative 6, we're going to get negative 4 equals log base 2 of x. So x is going to be 2 to the negative 4, which is 1/16. And since we need to find n plus n, 1 plus 16 is going to be 17, so that's our answer. So this is problem number 3. It says a positive integer n has base 11 representation ABC and base 8 representation 1BCA, where A, B, and C represent not necessarily in distinct digits. Find the least such n expressed in base 10. So the first thing we got to do in this problem is convert ABC in base 11 and 1BCA in base 8 to base 10 and make them equal to each other, right? In order to find A, B, and C. So in base 11, ABC converted to base 10 is going to be 121A plus 11B plus C. And in base 8, 1BCA is going to convert to 512 plus 64B plus 8C plus A. And if we move all the variables to one side and leave 512 on the other, we're going to get 120A minus 53B minus 7C equals 512. Since we want the least value of n, we need to find the least value of A, B, and C, or the least value of A, B, C. So A is going to be 5 at the very least, since it makes it 600. And if this is 600, then we know that 53B plus 7C has to equal 88. So 53B plus 7C equals 88. The least possible value of B we can have is 0. But if we plug in 0 here, C wouldn't be an integer because 88 divided by 7 isn't an integer. So if we try B equals 1, then we have 7C equals 88 minus 53, which is 35. And this actually works because C would be 5 now. So we have A equals 5, B equals 1, C equals 5. So least such n expressed in base 10 is going to be 515. So that's our answer.